Okay, this is group 25 for project 2. I'm Jamie Andruzzi.
I'm Connor Layden.
And I'm Joe Rogaski.
Alright, so for our group's problem, we were given 3 different things. We were given that the initial velocity was 0 as it started from rest. We have the mass, the weight of the gears, which was 10 pounds each, and we have the weight of the plunger, which was 40 pounds. So this is our figure right here. You're going to have the plunger in the middle, which is going to go in the downward direction. You're going to have the 2 gears on each side with both a radius of 8 inches. So to find the mass of the plunger, you're going to take 40 pounds and we divide that by the acceleration due to gravity, which is 32.2 feet per second squared, and you're going to get an answer in slugs. So we're going to do the same thing for the mass of the gears, just with 10 pounds divided by 32.2. So then we are going to calculate the moment of inertia for the gears, because you're going to need that later on in your calculations. So you're going to use the formula 1/2 mr squared, just plugging in the mass that you get in slugs and using the radius in terms of feet. And so in this problem, you're going to be looking for the velocity of the plunger at time equals 1, the angular velocity at time equals 1, and the velocity of the mass of the velocity of the plunger if the mass of the gears is neglected.
Okay, so we're going to start by analyzing the movement of just the plunger. And as you can see from this figure, we have a symmetrical system, so we can cut this system in half. And in our free body diagram here, we're using half of the plunger. So we have the force of friction acting in the positive y direction, and we have the weight of the plunger acting in the negative y direction. So here we sum the forces in the y direction. We have the sum of Fy is equal to the force of friction minus 20. Then we use this equation and we plug it into our linear momentum equation. We integrate and then evaluate from t equals 1 second to t equals 0. And we come up with this equation here. F minus 20 is equal to 1.24 V2. And then we can take advantage of our equation here. V is equal to omega r. And we plug this in for V2 and we come up with this equation 1 here. F is equal to 1.24 times 8 over 12 omega plus 20.
Okay, so after finding our linear momentum equation, we need to take a look at a free body diagram for one of our gears and find the angular momentum equation for the gear. And doing so, and using the moment of inertia we previously calculated, we find that 0.667 F equals 0.06901 omega, and that will be our equation 2. And just looking at equation 1 and equation 2, we see that we can easily, since we solved for F, we can plug it in and solve for omega. And solving equation 1 and 2, we find that omega equals negative 27.659 radians per second. And the reason it comes out negative, but we took it away, is because of the right hand rule, and that this gear is rotating like this with my thumb pointing into the board. So you would get an answer that is negative, and that would be the correct answer.
So doing another quick calculation, we are going to utilize our equation velocity equals omega r, just plugging in this omega and using our r of 8 over 12, and then you're going to get a velocity of 18.439 feet per second. And that's going to be the velocity of the plunger falling at time equals 1 second.
So if the mass of our gears is 0, the inertial torque of them is 0. Therefore, our plunger is essentially in free fall and is only affected by gravity. So we can plug in to this equation here and get a velocity of 32.2 feet per second.
Woo!